here again we are going to find out the derivative of another trig function, that is a times under root tan 5x minus 7. Alright, so let me suppose this is my function y equals a tan 5x minus 7, and this quantity was inside the root. So here, in this question, if you see, this a is just a kind of coefficient, so you can keep outside, right, while differentiating. So let's differentiate both sides with respect to x. So we'll get now a is a constant quantity and it's a coefficient, you can say, of tan 5x minus 7. So let's keep it outside, and now let's find out the derivative of these things. Derivative of tan 5x minus 7, alright, and this was inside the root. But one more thing I want to say, if you don't want to put the root, then you can remove it and you can put the half here as a power, because root over x can be written as x to the power 1 by 2. Alright, now with respect to dx. But one thing is here again, like this tan 5x tan 5x minus 7 is raised to the 1 by 2, and here this tan 5x minus 7 will work as a base whose power is half, but here we're differentiating with respect to x, so these two things are not going to match. So we have to differentiate with the matching thing, and matching thing should be with the base. So we have to, in next step, we have to differentiate with respect to its base. Right, so my constant quantity outside, and I'm going to differentiate this now. Derivative of tan 5x minus 7 raised to the power 1 by 2 divided by d tan 5x minus 7. Alright, because this was my base here, tan 5x minus 7 was my base, so I differentiated with that. And one more thing, like here, if you see, this d tan 5x minus 7 was not here initially in this first row, so I applied, I divided, so I have to multiply also. So derivative of tan, again, 5x minus 7. Alright, and now again, to differentiate these kinds of things, tan, whenever tan, sine or cosine or cot, anything have the power 1, in that case we used to differentiate, as here it is power 1, we used to differentiate that with respect to its angle, and angle is here 5x minus 7. So again, in this case we have to differentiate with respect to its angle, which is 5x minus 7, and again times, again I have put this from my side, so I have to multiply it also, 5x minus 7, and again divided by, now my original dx, I'm putting here dx, because I can easily differentiate this 5x minus 7 with respect to x, because x is the main variable here, alright, main function here, because a little change in x can change the value of this 5x minus 7. And now see, this is a way, like the way I did here, this is a kind of way to do to find out the derivative. You need to follow that at every step. If you're doing one by one, it's gonna take a lot of time. So at one place I did it, alright, I divided, I multiplied, again I divided, I multiplied, and I'm finding out the derivative also in the same time. Alright, so here a, this is my coefficient, and now I can easily apply the power rule here. That was the concept I was doing here. So see how is the power rule again. If you have x to the power 5 and you're going to differentiate with respect to x, it doesn't look like 5. Alright, so it is 5 times x to the power 5 minus 1. Alright, it's something like this, derivative of power rule when we use. So same thing I'm going to do here. I have the power half, so power times the base is my 5x, tan 5x minus 7, so tan 5x minus 7, and whatever the power initially it had, minus 1. So initial power was half and minus 1. Again times, now let's find out the derivative of this part. So here tan 5x minus 7 over 5x d 5x minus 7, it is something like this. Derivative of tan theta with respect to theta equals to sec square theta. Alright, derivative of the tan angle over the angle with respect to angle is equal with sec square angle. So derivative of tan 5x minus 7 with respect to 5x minus 7 will be sec square 5x minus 7. Again times, now derivative of 5x minus 7, since 5 is a coefficient and a constant, so it will come outside, and then times derivative of x, that is 1, and minus derivative of 7 is a constant number, so it's 0, Now let's rearrange it. That's our answer. So it is a, this is 2, and this is 5. So I can write here 5a over 2 times I'm putting the sec square first, sec square 5x minus 7, and then whole divided by this part. It is half minus 1 is minus half, so minus half will go downstairs. It will be 10 5x minus 7. Alright, and you can write whole to the power half in downstairs. But if you don't want to write here half power, then you can do one thing. You can remove this power and you can put the root here. Alright, let's put properly. You can put root here as it was originally in the question, because I have already told you if x has the power half, we can write root x, or if root x is there, we can write x to the power half. So this was our required derivative of the given function, a times under root 10 5x minus 7. This is our answer. That's it. Alright, I hope you got this concept, and we'll be doing more problem that will give you more concept. Catch you in the next video. Goodbye.